In this video, we are going to be talking about work and power. So by the end of the video, you should be able to compare and contrast work and power. You should be able to use the equation for work, which is work equals force times distance. And you should be able to use the equation for power, which is power equals work divided by time. So what is work? Well, work is the product of the force applied to an object and the distance through which that force is applied. So basically saying it's the amount of force that you apply to an object and the distance that object goes because of the force you applied to it. And the equation we use to calculate this is work equals force times distance. And from previous lessons, we know that for force is newtons and the unit for distance is meters. And when we take force times distance, we get a unit of 1 Newton meter, or also what we like to call a joule. And that is the unit that we use for work. We use joules and we symbol it with a uppercase J. So in these examples here, I wanted to talk about whether work is being done or not. So the first one is mowing the lawn. Work is being done because you're applying a force. Even if it's a self-driven lawnmower, you're still applying some kind of force to keep it moving, to move it faster, to move it slower, to turn it, whatever it may be. And you're going a certain distance, you're mowing your lawn, you're going back and forth on your lawn. So work is being done. The same thing with weightlifting. You're applying a force to move the weights and you're moving the weights a certain distance. Same thing with moving furniture up a flight of stairs. You have to apply a force to get the furniture up off the floor and then you're going upstairs, so you're moving from one point to another. Now if you're pushing against a locked door, yes, you are applying a force, but the door is not moving anywhere. So let's say you applied 400 newtons of force, but since the door isn't going anywhere, your distance is 0. So you end up with a number of 0 joules, which also means no work. If you're swinging a golf club, you are applying a force to the golf club and getting it to swing from point A to point B. So the only one from these examples that no work was being done in was pushing against a locked door. So what to take away from this is, in order for work to be done, you have to be applying a force and the object has to move from one point to another. It can't stay in the same place. So do you do more work when you finish a job quickly? Well, as we know from the equation, which is work equals force times distance, work doesn't involve time, only force and distance. So no work is done on an object when you're standing in place and holding the object, or again, when you're pushing on a locked door. So when you do work and finish a job quickly, you're not doing any more work than you would have if you would have finished the job at a normal time. It's just you're going faster. So if you decided that you were going to run up a flight of stairs, go back down the stairs, and then go up the stairs skipping 2 at a time, would you be doing more work in this case? Well, you could be if you're applying more force, but you're not actually doing more work because in theory you're still applying the same force and you're going the same distance. You're just doing it faster. So if there's ever a problem that says somebody dug a hole and was able to do it in 2 hours, and then another person dug a hole and was able to do it in 4 hours, which person did more work? Well, in reality, they did the same amount of work because they dug the same size hole. It was just the fact that they dug this hole, one dug this hole faster than the other. So let's do a little bit of practice. So if you lift a 400 Newton classmate up 2 meters, how much work did you do? So don't forget, our equation is work equals force times distance. And we know from previous knowledge, from previous lessons, that Newton is a unit of force. So we know our force is 400 newtons. And again, from previous lessons, we know that meters is a unit of distance. So we know 2 meters is our distance. So now we need to take 400 newtons times 2 meters to get an answer of 800 joules of work. So when you lifted this classmate, you did 800 joules of work to get this classmate up 2 meters. Let's try another one. So if you push an 800 Newton box 8 meters, how much work did you do? Well, again, the equation equals work equals force times distance. And our force is 800 newtons. Our distance is 8 meters. And if we take 800 newtons times 8 meters, we should get a work of 6,400 joules. So pushing the 800 Newton box 8 meters takes 6,400 joules of work to do that. So now let's talk about power. So power is the rate at which work is done, or the amount of work that is done per a certain time. So if 2 people mow 2 different lawns that are of equal size, and one person does the job in half the time, who does more work? Remember, time does not have anything to do with work whatsoever. So they did the same amount of work, but one exerted more power than the other because power does involve time. So our equation for power is power equals work divided by time. And the units that we use for power is watts. And you may have heard of these before. Watts are used to measure the power of light bulbs and small appliances in your home. So if you've ever replaced a light bulb at home and you have been told you need to make sure that you put a 60-watt light bulb in that light socket, that's because the light bulb then can handle the power that is being put into that light socket. Electric bills, something you may have never seen but you've heard of, are measured in kilowatts per hour. So it tells your parents how many kilowatts of electricity you are using per hour in a day. And 1 kilowatt is equal to 1,000 watts. So in reality, when they're looking at your electric bill, they're seeing that you're using thousands of watts of power per hour or per day. So when we use kilowatts per hour for electric bills, it's just so that the number doesn't look as terrifying as it probably would if we put it in watts. So let's do some practice with calculating power. So you exert 50 newtons of force over 6 meters in 10 seconds. What power did you generate? So one thing you may notice is that there is no number for joules in this problem. So that means this problem is a 2-step problem, because our equation for power is power equals work divided by time, and work is measured in joules. So the first step that we're going to have to do is calculate work. So we need to take our work equation and take 50 newtons multiplied by 6 meters to get 300 joules of work. Now we can take this number and put it into our power equation. So 300 joules divided by our time, which is 10 seconds, and we should get a number of 30 watts of power. So you generated 30 watts of power while moving while exerting 50 newtons of force. There is another way that you can do this problem, and some of you may already figured it out. You can skip doing two separate equations, and you can put the work equation right in here. So it would look like this. And you can do it this way. It still gets you the same number because you're still doing all of the same steps. But I would like you to do it whatever way is comfortable for you. So if you want to do the two separate equations, please do. If you feel like combining the equations and doing it in more like one step is the way you want to go, please do. So let's do another problem. If you exert 10 newtons of force over 1 minute in 5 seconds, what power did you generate? Again, we have to calculate work because I didn't give you any numbers in joules. So we need to take 10 newtons times 1 meter. Well, we're going to get an answer of 10 joules because 10 times 1 is 10. And now we're going to take 10 joules divided by 5 seconds to get an answer of 2 watts. So you generated 2 watts of power when you exerted 10 newtons of force. Now, we're going to talk about horsepower. And you guys have probably heard of this when it comes to talking about cars, lawnmowers, anything that has an engine. But the term horsepower was developed to quantify power. It was so people could get a better idea and kind of depict in an easier way how much power was being exerted, how much power something has. So a strong horse could move a 750 Newton object 1 meter in 1 second. So when we talk about horsepower, we're also talking about the fact that 1 horsepower is equal to 745.5 watts. So if 1 horse was doing work, they were able to do 745.5 watts of power. So let's try to do this. So how much horsepower do you have if your power was 1,528 watts? Well, some of you may know how to do this, and I'm going to do my best to set it up the way that you guys know. So we're going to put 1,528 watts over nothing, or you can put it over 1 if that makes you more comfortable, multiplied by the little conversion that I gave you in the previous slide, which was 745.5 watts over 1 horsepower. So the reason I put the watts on the bottom was because you need to cancel the unit of watts out. And don't forget, when you take 1 divided by 1, they cancel each other out. So the same thing with the units. You take watts divided by watts, they're going to cancel each other out. So now let's do the math. You're going to take 1,528 multiplied by 1 to get 1,528, and then divide that by 745.5. So your answer for this problem should be 2.05 horsepower. So if you had a power of 1,528 watts, you have the power of about 2 horses, which is kind of miraculous. So let's do a little bit of recap on the lesson. We know that work is the amount of force applied to an object and the distance that that object goes because of the force. We know that the equation for work is work equals force times distance, and the units that we use for work are joules. We know that power is the amount of work done in a certain amount of time, And we know that the equation we use for power is power equals work divided by time, and the unit that we use for power is watts. We also know that 1,000 watts is equal to 1 kilowatt, which is also used to measure your power bill. And we also know that 1 horsepower is equal to 745.5 watts. So this wraps up the end of this lesson. If you have any questions, make sure to write them down in your journal. Otherwise, if you feel they're pretty important, please email me or text me, and have a great day.